Right. Good morning. We are starting our live. Yeah. Now this is going on live. Motion in a straight line. That is our work today. We have to do motion in a straight line. When we think of motion in a straight line, we want to think of some concepts like if you consider the motion in a straight path of any object, an object can be moving from one place to another, and its motion can be different way. So it can take the path a straight line, and it can take a long way where uh, a constant direction is not there. The fixed direction is not there. So there's a difference between the motion between 2 points in a straight path as well as the shortest path. So we have to consider both. And if you consider the motion in a long way, it is we consider the distance and distance, right? But if you consider the motion between 2 points with the shortest length of the path with a fixed direction, so we have their displacement. So with that displacement, right, with that two concepts, we can move. And there are some other phenomena that related with the motion of an object between 2 points, and that is the relationship between the time. So you have a distance and you have displacement, then you have time, because you consume both. When you are moving from one place to another, you consume both in the sense you can consume distance and time, you can consume displacement and time. And as a result, that you will get some other concepts like speed. You can have the speed, and then you can have velocity. So let's go and study step by step, revise what we have learned from that motion in a straight line. Not only that, there are some other things that we have to relate. That is motion in a straight path, and how they are going to connect with the graphical representation, which is very much difficult for somebody to understand the graphical representation. So you can have distance here, and then you can have the time. So we are going to see what relationship is there with the distance and time, and then the idea that is given by the graph, how to read it and how to understand that. So those are the things we want to discuss in this unit. The very first part is going with the equations and understanding the relationship between this distance, time, and displacement and time. Well, as usual, we are going to discuss this by using the questions and the answers. We have already discussed the first unit of grade 10, right? Let's get into our question page. Coming early in the morning, very good morning. Right. This
Good morning,
is
sir.
very good morning. It's a little bit warm here. A little bit warm. Well, as you can see, my question is We are discussing, yeah, we are discussing. I must you get in late and come in late. I want to have the red line. Normally, I like to work with the red line here. I forgot to prepare that one before the class. Oh. Wow. Question number, yeah. I'm going to start a new question number because we are in a new line. Right. This is, we discussed question number 28. Shall I go as 28 or 28? Yeah. This is the second unit and motion in a straight line. Motion in a straight line or path. Motion in a straight line. Today is 7th, 18, 20, 21. My first question, distance and displacement, question number 1. Question number 1. Question number 1. What is the difference between, what's the difference between distance and displacement? What is the difference between distance and displacement? Well, when we discuss the answer for this one, distance, of course, distance has only magnitude, whereas the displacement has both distance and both magnitude and direction. Second, define the displacement. Define the displacement. So when you define displacement, what is displacement? The shortest length of a path between 2 points. Between 2 points that an object travels to a particular direction. You have to mention about the direction as well. And it should be the shortest length of the path. The shortest length of a path between 2 points that an object travels to a particular direction. The displacement, yeah. Third one is distance a vector quantity. Vector quantity. Explain the reason. Explain the reason. Is distance a vector quantity? What is your answer? What is your answer? Yes or no?
No.
No. The answer is no. The reason is for something to be a vector quantity, it should have both direction and magnitude. Direction and magnitude. The distance has only the magnitude. Direction has only the magnitude. So when we go for the other one, the displacement, it is a vector quantity because it has both the direction and the magnitude. The direction and the magnitude. Fourth one. Now, we are step by step going into the lesson. If you have not covered the second unit perfectly, I believe that this part would be very nice for you to understand right from the basic, because most of you find it difficult to understand what it says. That it has simultaneously going two concepts that go simultaneously. I mean, in one way, it changes its distance or its displacement, whereas the other way, it consumes the time. And we want to see the both relationship. So my next question, an object traveled, TRAVELED, an object traveled 150 meters in the following way. So I'm going to show you the way that it traveled. So start, this is the initial position. It went up like that, and then 150 covered. And I stop here. So this is the direction of the path, and this is initial position. And this is the final position. So the shortest path between these 2 points that I'm going to show you it is this one. This is the shortest length of the path. And if you are to find out the direction, it is the north over here. So this is north. And the north over here. The angle between these 2 points is 60. Now, an object travels 150 meters in the following way. So the total distance over here is 150, and this one is 60 meters. Right. Now I'm going to ask you about the distance and the displacement. Distance and displacement. First question. What was the distance that the above object traveled? What was the distance that the above object traveled? The answer is 150 meters. If you feel like supporting me, now mostly I welcome you mostly because it's early in the morning that I am all alone here in a nice studio. Second one, what was the displacement? What was the displacement? What's your answer? It's just only the 60 meter? Is it 60 meters? Yeah or no? What is the displacement? Was it 60 meter, or what should I consider when expressing the displacement? Hey, come on, there are many boys and girls over here.
Uh, 60 degrees at the direction of 120 degrees from the north to south.
Well, let me explain. Thank you for your explanation. Let's see how we can express the displacement. Okay. When we are expressing the displacement, as I told you, we want to express the direction as well. Now, according to this question, this is north, and the object travels how? The object travels like here, and it goes and goes on, and then stops somewhere here. And from the initial position to the final position, it says 60, 60, yeah, 60 meters. So this is 100 and, what was the distance? 150 meters, right? 150 meters. So when we are expressing the displacement, right, you have to consider the main directions. You can have the main direction. So the answer here, the angle is 60 degrees. Now you can consider either north or the south. But if you say 60 meter in the direction 60 degree from north, right? I will say again, 60 meters in the direction 60 meter, 60 degrees, 60 meters in the direction 60 degrees. So that means you can have other side as well. So you can have the other side as well, right? So you get confused. I mean, this is also the same, right? You can say, oh, this is bigger. You can write here. If you say 60, as Nipuna said, you can say 60 meters in the direction 60 degree from north to south. This is also can be expressed in that way. And this also can be expressed. So what you have to consider is from south to, you can mention the other direction. What's the other direction? You can select from here, which one? North, this is east. Am I correct? This is west. So you can say 60 degree from south to
East.
south to east. South to east. Then that problem is avoided. I mean, 60 degree from, sorry, 120 degree from north to south. You can say that this way also, both sides you can consider. Just like here, you say 120, right? 120 from north to south. And this is also 120 from north to south. Confused? So in order to avoid that confusion, we could say 60 degree from south to east. So first you mention the magnitude. First it is the magnitude, and that is 60 meters, right? 60 meters. Then the direction, 60 meters in the direction 60 degree from south to east. South to east. I think you could understand what I say. Did you? Could you understand what I said? Clear?
Yes, sir.
From south to east. So I'll come to the question before that. Let's consider another occasion, because these are the areas that we get confused. So we want to go. And here is again another one. This is the initial position for some object. And start in go, 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 and then stop over here. This is 250 meters. So the angle between the shortest length of the path between these 2 points, this is initial position, this is the final position, and between 2 points, it is 120 meters. So this is the main direction. So you can have 89, 90. Good. So this is north, and this is north, and this is west. Right. So you can have north, right? The angle between this one here is 110 degree. So then how are you going to express the displacement? How are you going to express the displacement? What can you use for expressing the displacement? Let me know. Yeah. What should I write first? What should I write first? Come on. Could you please tell me the displacement of this object. Don't put me in trouble, my dear. This is going live.
120 meters.
120 meters. Next.
In the direction of 70 degrees from north to west.
In the direction, D-I-R-E-C-T-I-O-N, in the direction, yeah. What is the distance, the angle here? 70, right? From north to east, the west,
West.
west, in the direction 70 degree from north to west. In the direction from north to west. It is, so you can locate it exactly now where it is. 70 degree from north to west, right? Well, this is how the displacement is expressed. So we can go for the questions that we have been discussing, and let's consider the other one. Where up to now, I think you are okay with what we have discussed. We have been discussing. Going to the next question. Well, it is, what was the displacement? How are you going to write it? Yeah. The displacement is 60 meters. 60 meters in the direction 60 degree from south to east. South to east. So this is how the displacement is expressed. So you have to mention the direction and you have to mention the magnitude as well. Moving to the other part, third question, third part of the same question. Third part, if the object took 10 seconds to travel, simple A, find the speed. Simple B, find the velocity. Okay, find the speed. If the object took 10 seconds to travel above distance, we want to find out the speed. The simple A, speed equal distance traveled divided by the time taken. So the distance traveled equal 150 meters and divide by 10 seconds. So finally you will get 15 meters per second. 15 meters per second is the speed. Simple B, velocity equal velocity is the displacement divided by time. Displacement, we know it is the shortest length of the path, 60 meters. Shortest length of the path, 60 meters. And divided by 10 seconds, it is 6 meters per second. Now somebody might ask, sir, if velocity is a vector quantity, how are you going to show the direction? For the velocity, the direction is the positive and negative value here. You can put a positive mark, negative mark to indicate the direction. If this is negative, then you know that the displacement is to the opposite direction. Now we are going gradually to understand a little bit complicated part after this one. Now it is very clear that we have started to discuss about the initial position, final position, distance, displacement, and how to express the displacement, and then the relationship between the time. Let's go further to discuss about the displacement and the velocity. Question number 5. Question number 5. Question number 5. An object traveled. 1 second. Yep. An object traveled. An object traveled 20 meters to north and turned around, turn around and traveled 60 meters. 60 meters. Simple A. Depict the motion in a diagram. In a diagram. B. Find the distance traveled. C. Find the displacement. D. Find the velocity. Velocity if the object took 5 seconds to travel. So an object traveled 20 meters to north and turned around and traveled 60 meters, and depict the motion in a diagram. So first we want to identify the distance, and we want to identify the displacement. We'll see. I'm going to discuss this one by using the board over here. Right. If you contribute whenever I ask the questions, that lesson would be very colorful, and you will get more out of it, and while you are supporting the others as well. The first one, what we want to study is the object travel 20 meter to north. So very first thing we want to make it clear is the initial position and the final position. Initial position and the final position. Okay, let's see. If I consider this is initial position, let me check. Yeah, this is the initial position, right? So you have initial position. This is the initial position. Initial position. Then it travels to north, indicating the direction over here. It travels, the distance is 20 meters to north. So the path is straight and travels 20 meters and then stop there. And after that, turn around. It means, turn around means it takes the same path back. Turn around. The meaning of turning around is, okay, turn around. Turn around, right? It's going to come back and continued 60 meters. So turn around and continued 60 meters. Here there is 20 and should travel another 40. Should continue another 40. So this is then the final position. You got the final position. Final position. And this is the initial position. Now this is the final position. But it traveled up and then came down. Now the concept. When it is the distance, you want to consider the total length of the path that it traveled. The total length of the path. So he went up 20 meters and then another 40 meters over down, right? The distance when you think of, you want to consider the upward movement and then the downward movement. So this is the distance. This is the distance. And if you consider the displacement, and this is the displacement. So when we think of a distance, it is something like this. It is something like this. Let me have the blue color. Yeah. Distance can be find out upward movement, upward motion. Upward in the sense the north plus downward, downward, D-O-W-N-W-R-D, downward motion. So the upward is 20 meters plus downward 60, downward 60 meters. So its distance is 80 meters. So it traveled 80 meters for the whole journey. But when you think of the displacement, how can you find out the displacement? that is the place, that's the point we want to consider exactly. Now let's see how the displacement can be. You want to consider the particular direction and the opposite direction. So when we think of the displacement, yeah, this is the boundary for you to indicate the initial position. So this is initial position. Initial position. And the area over here is the particular direction. Particular direction. And the other side, it is the opposite direction. Opposite direction. You have opposite direction. Now, initial position, particular direction, opposite direction. Then I can say 40 meters to south. You can say 40 meters to south. Or the other way, I can mention by putting the negative mark. So negative 40 meters. Why? The displacement is the initial position and then final position. What is your answer for the displacement? The displacement, yeah, like here, displacement. You can write displacement. It's not just only 40 meters. If you say just only 40 meters, this indicates that even though you don't mention here, the value over here is positive, then it will show you the particular direction. Particular direction. And then the object, you will, this shows that that object is still over here, somewhere the position over here. If you put only the 40 meters, as it is now remaining in the opposite direction, as it is in the opposite direction, so you have to mention that one. How can you mention that one? So you can say either negative 40 meters, negative 40 meters, or you can say 40 meters in the direction, of south. It is exactly in the south direction. Okay. I think this is clear, so we'll get back to our writing pad. Could you understand whatever things I mentioned here?
Yes.
Yeah.
Sir. Yes. Sir.
And these are the answers. Let's get into that. Right. Depict the motion in a diagram. Simple A. Simple A. Depict the above in a diagram. So I will write starting from over here. This is initial position. Initial position moving upward to the north. Upward motion. This is north. and that is 20 meters. Turn round, and stopped 40 meters in opposite direction. This is the final position. Final position, and that value is 40 meters. The total length is 60 meters. So you have to depict that one. And you can't mention the right. It's too hot over here. My little fan gives me the wind power. Simple B. Find the distance traveled. Distance traveled is 60 meters. Up 20, down 40. එන්නේ කොහොමද? To north 20 to south. I'm sorry, not 60. It should be 80. Am I correct? $20. It came 60 meters down. It should be 80, right? To south, 60 meters. Then altogether, 80 meters. Find the 20 to north and turn around and traveled 60 meters. Altogether, 60 plus 20, 80. Yeah. C. Find the displacement. Find the distance and find the displacement. So the displacement is equal. Now you want to find out particular direction and opposite direction. Displacement is negative 40 meters. If you say negative, you have already mentioned the direction. Or else you can write 40 meters in the direction of south. Both you can mention. Find the velocity if the object took 5 seconds to travel. Then we can write D. Velocity. Velocity equal displacement divided by time taken. Displacement is 40 meters. Negative 40 meters. And time is, what's the time it says? 5 seconds. The answer is how much? The answer is 8 meters per second. It gives a negative value because it is to the opposite direction, not to the particular direction. Okay. Now we have been discussing about the motion of an object, the relationship between the velocity and the displacement, moving to the other one. Going to understand the average speed. What is average speed? Question number 6. Question number 6. What is meant by average speed or mean speed? Mean speed. What is meant by average speed or mean speed? The answer is the total distance. Yeah. What is mean speed? The speed taken by dividing the total distance traveled, by total time taken. Total time taken. It means, so you can say average speed equal total time and divided by, total distance divided by total distance divided by total time. Total time. Example. 7th question. Example. Example. A bus started its journey from a city at 8 a.m. and traveled 20 kilometers. Then stopped at a bus stop for 5 minutes. 5 minutes. Then traveled another 40 kilometers and reached to the final city. Final city at 9 a.m. 9 a.m. Find the average speed. Find the average speed. Yeah. The bus started its journey from a city at 8 a.m. and traveled 20 kilometers. Then it stopped at a bus stop for 5 minutes. So we are not worrying about the time that the bus stopped, even though it stopped 5 minutes or 10 minutes or whatever the time, we don't worry. What we have to consider is the total time taken. So the total time taken is 1 hour. So we can write the speed, now average speed. Average speed is equal total distance traveled divided by total time taken. So the total distance traveled is 40, 20 plus 40, 60 kilometers. 20 kilometers plus 40 kilometers divided by 1 hour. 1 hour. That is 60 kilometers. 1 hour. The answer is 60 kilometers per hour. 60 kilometers per hour. And that's the average speed. Right. Going to find out from here. Yeah, the velocity. Now, when we just think of going to show you the relationship between the velocity and time. Velocity and time, right? There we can see that the velocity and the displacement time, velocity, time, displacement. How to find out this information by using a table, tabulating, right? And finding the information about that. Look at here. I'm going to draw a table and put some information into that one and to read the motion, right? This is a table. And going to put some information onto the table. So you have 1, 2. Are you all right? We got only limited time to go because some are coming still right now, right? Yeah. So I can write. This is sorry. I have to have another one over here to indicate the time. This is time, and this is, so you got, yeah, you got the time This is time, displacement. So you got the time and displacement. When the time is 0, the displacement is 0. Time is 5 seconds, time in second, displacement in meters. 5, when the time is 5 seconds, displacement is 20. When the time is 10 seconds, displacement is 40. When the time is 15 seconds, displacement is 40. When the time is 20 seconds, displacement is 40. When the time is 25 seconds, the displacement is 20. And when the time is 30, right? Went correctly, right? 5, 10, 15, 20, 25, 30. The displacement is 0. So we want to understand what this says. If you can read this table, the tabulated information, so we can answer some questions. For some, it is difficult to understand what actually this says. Let's consider. When the time is 0, the displacement is 0. We want to consider, in this occasion, initial position and the displacement. I'm going to show you in the real situation, whatever the information given in the table. So look at here. Now I have two areas in my chart. One, this is the initial position. This is the initial position. Okay. This is the initial position. So you can have initial position. You can have the initial position. You can see, right? Initial position, initial position. So if this is initial position, right? This says by the time it is, when the time is 0, displacement is 0. Okay. Object is at the initial position. Then when the time is 5, displacement is 20, not negative 20 meters. That means if you consider this is particular direction, I mean the direction that we are looking at, the observer is facing that direction. The observer is facing that direction, looking that path. And if you want to turn back and to see the other area, means that it is in the opposite direction. It is in the opposite direction. Now, let's consider this one. It is when it is 5 seconds, it is 20 meters. That means the object has moved to here. Now the gap is 20 meters in the particular direction. When the time is 10, it is 40. 40 means from the initial position. That means it has traveled another 20 meters, making all 40. And when it is 15 seconds, right, the time went on, the time goes off, the 40, that means it remains in the same position. When it is 20 meter, 20 seconds, still it is 40. And when it is 25, now it is 20. That means it has turned back. It has turned back. And now it's going towards the opposite direction. When it is 30, so it has come to the initial position. That means 0. The displacement, look at here, the shortest length of the path, and the shortest length of the path from initial position to the final position, right at the time when 0, that it is 20. When it is 5, it is 40. So from the observer, the object has traveled 40 meters. When 20 is still, it is there. When it is 25, it is, 20, it is still there. 15 is still there. And 25, now it is coming towards the observer. So we don't put a negative mark here. If you put negative mark, that is opposite direction. It is in the opposite direction. That means he has already passed the initial position or the observer. And finally, it comes to the 0 position. So then the questions can be asked, what type of motion can be seen within the particular period over here? What sort of motion can be seen here? Right. The answer is what? What is your answer? During 10 to 20 seconds?
Object is at rest.
Yes, the object is at rest. Object remains. The object remains in a position of 40 meters from initial position without moving. What can you tell about the motion between 20 to 30 seconds? What can you tell about the motion from 20 to 30 seconds? Yes?
Uniform velocity.
No,
Object has come to the initial.
the object has turned round and come to the initial position. The object has turned around and come to the initial position, as you can see here. It moved forward, turned around, and came. But here, actually, it is stopped there. It is stopped there. Okay. And overall, if you consider this, you might see that you can have the constant velocity and constant velocity and something like that. We discuss that one later. See whether you can see whether constant velocity is there. Right. Getting back and write down that one in our question, so you can make it clear for your future reference. Up to now, hope that you are okay with my lesson. Are you? It is worthwhile of watching this one and all. Yeah. It takes a longer time than expected to connect. Why is that? It says can't connect. Stop sharing. Stop sharing. Go. Share. No result. We are unable to find. I don't know why. What happened? Wi-Fi is there. If Wi-Fi is there, why doesn't it share? Why doesn't it share? Let me check. Mhm. There's a little technical error here. Seems to be. Okay, correct it. Now it might be okay. Yeah, there you are. Low power. The router seems to be get low power. 8. Question number 8. The chart given below, the table given below, the table given below shows some information of the displacement the table given below shows some information of the displacement of a certain object within 30 seconds. Going to draw the table. Going to draw the table. So you have the table, first part, second part. For you to write time and displacement, first cage, second cage, next one, next one, next one. How beautiful it is to see the morning. We all don't have that. Well, this is time. In second. Displacement in meters. 0, 0. We put 5, 20, 10, 40, 15, 40, 20, 40, 25, 20, 30, 0. Right. My first question, the first question is, who came late to the class? Harun answer. Right. My first question. Where was the object when time is 0 second? Second question. Find the velocity of the object within simple A, 0 to 10 seconds. Simple B, 10 seconds to 20 seconds. Simple C, 20 seconds to 30 seconds. Question number 3. What can you tell about the motion of the object in A, B, C occasions mentioned above? Photo. At the time of 30 seconds, where was the object? At the time of 30 seconds, where was the object? First one, where was the object when time is 0 seconds? The answer is when the time is 0 seconds, where was the object?
Initial position.
Down there.
Initial position.
At the initial position. The answer is yes. At the initial position. At the initial position. Find the velocity of the object within 0 to 10 seconds. Part 2. Simple A. 0 to 10 seconds. 0 to 10 seconds. That means here 0 to 10 seconds. So you want to find out the velocity. We are writing velocity equal final displacement minus initial displacement divided by final time, initial time. Final time minus, so negative minus initial time. Final displacement කියලා කියන්නේ මෙතනදී. දැන් final displacement කියලා කියන්නේ 0 to 10 second. එහෙනම් final displacement එක 40. ඒ කියන්නේ 40 meters. Initial displacement එක time එක 0 වෙද්දී 0 meters. Final time එක කියන්නේ 40 කියනකොට 10 second. 10 second. Initial time කියන්නේ 0 second. එහෙනම් අපෙන් අහන්නේ velocity එක. එතකොට අපිට එනවා 40 meters divided by 10 second. 4 meters per second. So එයාගේ displacement එක එනවා 4 meters per second. ඊට පස්සේ B occasion එක. B එකේදී අහන්නේ 10 second to 20 second. 10 second to 20 second. අපිට උත්තරේ කියන්න පුළුවන්, හදලා පෙන්නන්න පුළුවන්. What I'm going to do is to show you how it is done mathematically. As usual, I'm going to write again velocity equal final displacement initial displacement divided by final t minus initial t. Final displacement එක අපි consider කරන්නේ 10 to 20 second. එහෙනම් 10 to 20 second. එහෙනම් final displacement එක 40 meters. Now issue I'm going to write 40 meters. අඩු කරන්න. Initial එක ඒ කියන්නේ අපි consider කරන time එකේ initial එකයි. අපි පටල ගන්නෙ නැහැ. Not the 0 one. The particular period we consider. So 10 to 20. Now the initial one is here. The initial one is here for that purpose. And the final one is here in that particular period. Right? So the initial one also 40. 40 meters. Final time 20 second. Initial time 10 second. 40 out of 40 is 0 meters, but 20 minus 10 is 10 second. When 0 is divided by 10, it is 0 meters per second. That means the object is at rest. Object does not have velocity. Object doesn't have velocity means object is not traveling. Right. And moving to the other one. The C. 20 second to 30 second. C. 20 second to 30 second. 20 second to 30 second. ආයමත් අපි ලියනවා. Velocity equal final අපි displacement එකට simple s දාන්නේ ඒත් අපි ලියනවා. Displacement minus initial displacement divided by final t time initial time. the final displacement එක දැන් කීයද? 30 second වෙනකොට 0 meters per second. 0 meters per second. Initial එක වෙලාවේදී අපි සලකලා බලන්නේ 20 second එකනේ. මෙතනදී 20 second එකේදී initial එක 40 meters. මොකද මේ 0 meters per second කියලාද? Per second නේ. Bit tired one. 0 meters 40 meters. Divide කරන්න. Final time එක 30 second. Initial time එක දැන් 20 second. එහෙනම් අපිට එනවා negative sorry මෙතන එන්න මම වරද්දුවනේ මෙතන එන්න කීයද 20 meters නේද final displacement 0 hari 40 minus 20 negative 40 meters divide by 10 seconds. The answer is negative 4 meters per second. The velocity is negative means the direction, the motion is to the opposite direction. The motion is to the opposite direction. It has a velocity, but not to the particular direction, as I mentioned earlier. So this is all about the motion of an object with the relationship between the displacement and time. And I'm going to take you to the, yeah. So, yeah, I'm going to take to the graphical representation. Graphical representation of displacement time. So it should show you how discuss the displacement time graph. What can you tell about the motion of the object in ABC occasions mentioned above? Yeah. A avasthavedhi, what can you tell about the motion? A avasthavedhi කියන්නේ මේ අවස්ථාවනේ. It travels with the constant velocity. ළමයි වුණාම උදේ පාන්දර නැගිටලා ලෑස්ති වෙලා තමන්ගේ ජීවිතය හදාගන්න දැනගන්න ඕනේ. එළි වෙලා තව විනාඩි 15ක් තියෙද්දි නැගිටලා ක්ලාස් එකට ඇවිල්ලා වැඩක් තියෙන්නේ. No use of, yeah. A. Object travels with constant velocity. B. Object is at rest. C. Object travels to the particular direction, with constant velocity. Object is at rest, the other one. Object was it? Unknown person has entered my digital board. Even a slightest insect can change this one because it's that much of sensitive. Yeah. The object travels to towards opposite direction within bracket to the initial position with constant velocity, with constant velocity. With constant velocity. All right. Now, the graphical representation of the displacement time graph. Question number 9. Question number 9. Right. A child wanted to තව ටිකක් කලින් එන්න තිබුණා නේද දරුවෝ? A child wanted to depict the motion of an object.
Sir,
Yeah.
අරක තව ප්‍රශ්නයක් තියෙනවානේ.
Agdiwada? Sorry. At the time of 30 seconds, where was the object? I'm sorry, my dear. A little bit tired seems to be my. දැන් ඉතින් මැසේජ් කරලා දරන්නේ නැහැ. මම කියන්නේ ඇත්ත කතාව. නේද? ළමයෙක් වුණාම උදේ පාන්දර නැගිටලා ෆෝන් එක ඔෆ් වුණාද ඒකයි ඔව්. උදේ පාන්දර නැගිටලා එන්න ඕනේ. මටත් එහෙම වුණොත් එහෙම ළමයි කී දෙනෙකුට හානිද? This is going live, right? I'm going to tell your name as well. Shall I? Okay. I'm sorry, my dear. At the time of 30 seconds, where was the object? At the time of 30 seconds, where was the object? When it is 30 seconds, the object, the displacement is 0 means it has come to the initial position. Yeah, the object is at the initial position. The object is at the initial position. Normally, I was here yesterday from 8 to 8. That means morning 8 to evening 8, keeping standing, talking, a bit tired. And again, starting right from 4 o'clock in the morning, Sunday, I seem to be a little tired. Anyway, we don't worry about that when we think of your future, even amid the pandemic situations that many people are struggling with many strategies. I came to know that the Ministry of Education, they have been planning to send you some worksheets that printed and to be sent to your doorsteps. So you will be working out them. I don't know what the plan or the objective of sending it, right? But anyway, we have been continuing this class, not this class, the theory classes every day, every Saturday. We have already completed the considerable part of your syllabus of grade 11 and 10. Therefore, no issue. Even still, you have some of the doubts. We have been discussing certain areas like this. So we got some revision classes on Wednesday and Thursday as well. A child wanted to depict the motion of an object in a graph in a graph. Simple A. Which axis is simple Roman number 1 or yeah, Roman number 1. Independent, which axis is used to, no, I will write used to above, is used to represent simple Roman 1 A, independent variable, independent variable to dependent variable. Simple B. If the graph is about displacement and time, if the graph is about displacement and time, 1. Which axis is for displacement? Displacement. 2. Time. Which axis is for the time? C. Show displacement and time on the graph. D. Draw the displacement time graphs for 1. Object travels with constant velocity from starting from initial position to constant velocity starting from 2 meters away from initial position in the particular direction. In the particular direction. 3. Constant velocity starting from 2 meters away from initial position and travels to initial position and then pass the initial position. Initial position. Fourth one. Object at rest at a point of 5 meters away from initial position of A in the particular direction. In the particular direction. B in the opposite direction. In the opposite direction. And 5 object is rest for 5 seconds and travels with constant velocity to the particular direction. B to the opposite direction. To the opposite direction. So I have given you a little task that can be used to discuss next day, coming Sunday when we get together. And remember, we have the most important part of this lesson next week, as we are going to discuss the graphical representations of velocity, acceleration, and some of the questions based on that. Did you finish your writing?
Sir,
Yes.
can I see the Roman number 3 question?
Roman number 3 question. This one.
Yes,
My handwriting is so beautiful because I'm writing by keeping a standing here. Okay. Finish off your writing. Please wake up before 4 and get ready and join with me in the class. I saw that 3, 4 of you came right at the time I started the class. I'm going to stop sharing. Is it okay?
it's okay, sir.
Okay.
It's okay.
And it's time to wind up the lesson. Hope you enjoyed my day, studying some things about the motion, and see you next Sunday as usual time. Bye then.
Thank you, sir.
Goodbye.
Thank you, sir.
Bye.
Goodbye, sir.
Thank you, sir.
You're welcome.
Yes, sir.
Have a nice.
Goodbye, sir.
Bye-bye.
Bye, sir.
Bye.
Goodbye, sir.